Statistics, Modeling, and Finance, Chapter 3, Measures of Dispersion, page 16, Standard Deviation.
Standard deviation. Now we come to a tool that has more power and can be used for further analysis when we get into inferential statistics. The definition of standard deviation is the square root of the variance. The sample standard deviation is the square root of the sample variance, and the population standard deviation is the square root of the population variance. That is the square root of the sum of the squared deviations from the mean divided by either the population size or by the sample size minus 1. How do we calculate a standard deviation? Standard deviations start out like average absolute deviations. We process a data set by calculating its mean and then compare how each observation differs from the value of the mean. However, with standard deviations, we square the actual difference. As with average absolute deviation, we use an absolute amount for the difference. That is, we ignore the sign, positive or negative. The squaring process also tends to magnify the effects of the variances from the mean. Here is the ominous-looking formula. S equals standard deviation. S equals the sum of x equals amount of the variate, x equals the mean, n equals the number of observations. I don't want to get too technical here, but the reason we use n1 is that in the calculation of the mean, we lose 1 degree of freedom from the sample. Degrees of freedom is defined as, in statistics, the number of values in a calculation of a statistic that are free to vary. For example, if a sample of size 4 adds up to a sum of 50, only 3 of the sample values can vary. Once the 3 varying sample items' values are ascertained, the 4th sample item value will be known with certainty, and must be equal to the unique number required to equate to a sum of 50. Therefore, the degrees of freedom in this example is n, 1 equals 3. So, the standard deviation formula builds on the formula for average absolute deviation. We sum up the differences between each observation and the mean and then square that. We divide that number by n1 and then take the square root of that number. Note, if you have difficulty performing the calculation on the HP12C financial calculator, there are a number of very good video tutorials on youtube.com. Just perform a search using this text, and it should come up with several brief videos that explain how to perform the operating on the HP12C. Search HP12C calculating standard deviation. End of page.